Working with numbers in standard form. This is also known as scientific notation. Learning intentions. Know what standard form or scientific notation is and switch to and from it. Use index laws to add, subtract, multiply, and divide numbers in standard form. Write final answers in proper standard form with sensible significant figures. Success criteria I can. Write any number as a times 10 to the power of n, with a being greater or equal to 1 but less than 10. Combine powers of 10 correctly. Add, subtract indices when multiplying or dividing. Match powers when adding or subtracting. Give the answers in standard form and round clearly using significant figures. Working with numbers in standard form. If you use your calculator to perform the operation 60,000 multiplied by 4,600,000, the screen will display the number 2.76 times 10 to the power of 11. This represents the number 2.76 multiplied by 10 11 times. The number 2.76 times 10 to the power of 11 is written in scientific notation or standard form. Standard form is a convenient kind of shorthand for writing large numbers and small numbers. This is the definition. So this yellow box is very important. A number in the form of a times 10 to the power of n, where a is greater or equal to 1 but less than 10, and n is an integer, so a positive or negative whole number, is said to be expressed in scientific notation or standard form. Here is an example, 6.8 times 10 to the power of 4. The 6.8, this part is written as a number between 1 and 10, and the 10 to the power of 4, this part is written as a power of 10. So what's in this yellow box is really important because this is often what you will see in the exam. It won't actually say, write this in scientific notation or write this in standard form. It will say, write in the form of a times 10 to the power of n, where a is greater or equal to 1 but less than 10. So let's have a look at an example of an exam question for Leaving Cert Ordinary Level Maths. Write each of the following numbers in the form a times 10 to the power of n, where a is greater or equal to 1 but less than 10, and n is an element of the integer set. So n is a positive or negative whole number. So we have to write 58,000 and 0.036 in standard form. So the important thing to note from the question is what I've highlighted here in yellow, which comes from the yellow box from our previous page, from our notes. So this is what you're going to see in the question, and this is what they mean by standard form. So they won't say the word standard form, they won't say the word scientific notation. This is what you will see, this is what they will say, but they mean standard form. So 58,000, we know that every whole number has a decimal at the end. So if you imagine there's an invisible decimal point after the last zero, and we're going to move that decimal point to the left until it goes after the 5. So remember that the A, the number in front of the multiplication symbol in our answer, the A has to be greater or equal to 1 but less than 10. So you're always going to move the decimal point so that it is just after the first significant figure. So we move it 1, 2, 3, 4 times. So we're going to have 5.8 now. And it's going to be multiplied by 10 to the power of 4 because we moved the decimal place 4 times. So we get 5.8 times 10 to the power of 4. So we do the smaller number in a similar way, except we have to go the opposite direction. We have to move the decimal point to the right now until it is in between the 3 and the 6, because we always want it to be just after the first significant figure. So here's the number, and the decimal is already drawn in this time. We don't need to put in an invisible one. We're going to move it once and then twice, so it's after the 3. So we're going to have 3.6 times 10 to the power of minus 2. So when we have a small number, we end up with a negative power. So some people like to learn off that if you move the decimal to the left, you end up with a positive power. And if you move the decimal to the right, you end up with a negative power. Or you can just think that if you have a big number, like 58,000, you end up with a positive power. And if you have a small number, like 0.036, you end up with a negative power. Here's another example using standard form from an exam question from Leaving Cert Ordinary Level Maths. Light travels at a speed of approximately 3 times 10 to the power of 5 kilometers per second. A light year is the distance travelled by light in 1 year. find the distance travelled by light in 1 year. You may assume there are 365 days in a year. Give your answer in kilometres in the form of a times 10 to the power of n, where a is greater or equal to 1 but less than 10, and n is an element of the integer set. So n is a positive or negative whole number. So again, it doesn't mention standard form or scientific notation, but this highlighted here in yellow is what tells us that it is scientific notation or standard form. So this question is about speed, distance, and time. So we're going to use Dad's silly triangle. So we're looking for the distance, so we cover up the D and we're left with S beside T. And two things stuck together, maths means multiply. So we're going to multiply speed by time to get the distance. So distance is equal to speed multiplied by time. So the speed is 3 times 10 to the power of 5 kilometers per second. And the time, we need to work this out ourselves. So we are told that the distance is traveled by light in 1 year. And our unit of measurement for speed is seconds. So we have to change from seconds to years. So we need to think how many seconds in a minute, how many minutes in an hour, how many hours in a day, and how many days in a year. So we start with the speed, so 3 times 10 to the power of 5. And we're going to multiply that by the time. So it's going to be times 60, times 60, times 24, times 365. So there's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year. So you can literally just stick this into the calculator and get your answer. So into the calculator, notice I've put brackets around the 3 times 10 to the power of 5 and then brackets again. And then my multiplication sign and then brackets and then 60 times 60 times 24 and then it's also times 365 and close my bracket. And you can write it down directly from the calculator. You get 9.4608 times 10 to the power of 12. So here are some numbers written in standard form. So 4,000 can be rewritten as 4 times 10 to the power of 3. 64,000 can be rewritten as 6.4 times 10 to the power of 4. And 254,000 can be rewritten as 2.54 times 10 to the power of 5. So I'm just going to show you the very quick way to work those out without using the calculator. So we have 4,000 and we know there's a decimal point, an invisible decimal point at the end of 4,000. And we're going to move it 1, 2, 3 times until it's just after the first significant figure, which is 4. So we get 4 times 10 to the power of positive 3. So it's a big number, so we have a positive power. Then we have 64,000 and again we have an invisible decimal point at the end of the number. So we're going to have to move it 1, 2, 3, 4 times until it's just after the 6. So we get 6.4 times 10 to the power of 4. And again, notice it's a positive power. Then we have 254,000 and there's again an invisible decimal point at the end of that 0. We're going to move it 1, 2, 3, 4, 5 places until it's just after the 2. So we'll have 2.54 and that's times 10 to the power of positive 5. So notice that if you move the decimal point 1 place to the left, it multiplies by 10 to the power 1. 2 places to the left, you multiply by 10 to the power 2. 3 places to the left, you multiply by 10 to the power 3 and so on. For numbers less than 1. For a number less than 1, we do the following. So I'm going to show you how to do this without the calculator in a minute. But just to show you in the calculator, 0.04 is 4 times 10 to the power of minus 2. 0.007 is 7 times 10 to the power of minus 3. And 0.068 is 6.8 times 10 to the power of minus 2. So on your calculator, there is an EXP on some calculators button, or it's a X10X key, which stands for exponential. To change the number 2.54 times 10 to the power 3 to a decimal form, key in 2.54, X10X and 3 and equals. So most calculators will have the X10X button. The calculator will display 2,540. So we have 0.04 and the decimal is already there, so we don't need to put in the decimal. And we're going to move it 2 places to the right so that it goes after the first significant figure. So our new number will be 4.0, you could say, or just 4. And it's going to be times 10 to the power of minus 2. because we moved it to the right this time, so it's -2, and we moved it 2 places, so that's where the 2 comes from. 0.007, so this time we're going to have to move the decimal point 1, 2, 3 places to the right. So it's going to be 7.0, or just 7, times 10 to the power of -3. So again, it's a minus because it's a small number, or it's a minus because we're moving the decimal to the right. And the 3 is because we've moved it 3 places. Here we have 0.068. We're going to move the decimal 2 places to the right so that it is just after the first significant figure, which is 6. So our new number will be 6.8 times 10 to the power of -2. So the 2 is because we moved it 2 places to the right, and it's minus because it's going to the right, or it's a smaller number. Calculations in standard form. Numbers in standard form can easily be added, subtracted, multiplied, or divided using a scientific calculator. So for example, 2.4 times 10 to the power 2 plus 1.68 times 10 to the power 3. You key into your calculator 2.4 x 10x 2 plus 1.68 x 10x 3 equals, and you'll get 1920, which you can rewrite into standard form as 1.92 times 10 to the power 3. Another example, if you want to see multiplication, 3.8 times 10 to the power 3 multiplied by 9.4 times 10 to the power -2. You key in 3.8 x 10x 3 multiplied by 9.4 x 10x -2 equals 357.2, and to change that into standard form, it'll be 3.572 times 10 to the power of 2. So some examples. Express each of these in standard form. So 2.76 times 10 to the power 3 minus 5.9 times 10 to the power 2. And then part 2, 6 times 10 to the power 3 times 4.5 times 10 to the power 4, all divided by 1.2 times 10 to the power 4. So for part 1, we key into the calculator 2.76 x 10x 3 minus 5.9 x 10x 2, and then press equals, and the result is 2170, and written in standard form, that's 2.17 times 10 to the power of 3. So you can see if we put it into the calculator, this is what it looks like. So there's your x 10x button at the bottom. And then for part 2, we key in 6 x 10x 3 multiplied by 4.5 x 10x 4 divided by 1.2 times x 10x 4 and equals, and you'll get 22,500. And this can be converted into 2.25 times 10 to the power of 4. So in your calculator, you can see that's what you would get. And then just to show you how we turn that into standard form without the calculator. So we move our decimal point 4 places to the left. So we get 2.25 times 10 to the power of +4.